On behalf of Bellefontaine City Schools and the Bellefontaine High School Amateur Radio Club, I want to welcome all BCS students, Bellefontaine community members, press, those watching this live stream around the world, and distinguished guests including Superintendent Hall and members of the Board of Education, Mayor Stoller, County Commissioner Bendetti, Mr. Volrath from the Chamber of Commerce, and Mr. Greg Brown from the Armstrong Air and Space Museum. I am Neil Kaufman, NDK, Vice President of our radio club. We have been preparing all year for this contact. Throughout the district, teachers have taken the opportunity to teach STEM lessons focusing on communications, radio, and space. Students have created artwork on space themes. We have heard from alumni of BHS who are now part of the space industry. Our club has given the opportunity to learn more about radio communications. I want to take a moment to recognize a few of the many people who helped make this contact possible. First, thank you to Evan Kaufman for his work writing the proposal and getting things rolling. Thank you to the parents for their help in planning and preparing for this contact. Thank you to Mr. Arbogast, our club advisor, and to Mrs. Horvath, whose tireless work has made this possible. Thank you to Gary Kaufman and Al Hockley and the rest of the Champaign-Logan Amateur Radio Club, W8FTV, to Tom Delaney, and to all the folks at ARRL for bringing the radio equipment and making the technical part of this contact happen. Thank you to Andrew Stevens and Chezzy D. Benedetto with the Ohio, Kentucky, Indiana Amateur Radio Society and DX Engineering for their help troubleshooting the antenna rotors. Finally, a big thank you to ARIS, including technical mentor Gordon Scannell and educational mentor Dan Warner for all of their assistance. In just a few minutes, we will be talking with astronaut Caleb Barron. But first, we will hear from a couple of BHS graduates currently working in the space industry. Then we will see a video from the ARIS program. Finally, there will be an introduction to Caleb Barron.
I've been passionate about the space exploration industry pretty much since like middle school. So by the time I was in high school, I was already following SpaceX and the crazy innovation that they were pushing. And I set my goal on working there one day. And to do that, kind of like getting ready for that, I joined a NASA student team in college, allowing me to work on projects before graduating. And then I worked really hard through high school and college and applied and did several internships there with them on the materials and additive team. Before starting full time. And honestly, there were definitely some tough times through like school and career challenges and personal life, but I just persisted and tried not to let anything hold me back, knowing that if you really want to accomplish something, you just don't give up, just refuse to give up. So I'm currently an additive manufacturing engineer. So I'm working on 3D printing our Raptor rocket engine for Starship, which is the vehicle that's going to take us to Mars. This is currently the largest rocket ever and one of the most powerful and complex engines ever built. I'm extremely happy just in general to go into work every day, to work on really cool projects with some of the smartest people in the world. Working at SpaceX is like working with all the people that you wanted in your student project teams in school. And I've been able to push the boundaries of 3D printing along with going into work every day to build rocket engines. So it's been amazing to overcome kind of the questions and feelings of what is or isn't possible, like what are we capable of? But I would say seeing astronauts and everyday people going into space on some of the launches and things that I've helped build is definitely like my proudest moment. It doesn't really matter like which part of STEM you want to be in, whether that's, you know, aerospace or medical or whatever you're going for, just not to get discouraged from failures. Some of the best scientists and engineers in the world fail regularly, but they learn from it. And if you're not failing, you're probably not trying hard enough. That's definitely like how I've learned the most, is by failures that just really concrete that in and challenge you in a way that you haven't been challenged before. But also just do everything you can to make time to figure out what you're actually passionate about on your path. Like, don't just push to a STEM path, you know, because that's what you do. Like, find something in that area that you really, really care about and love. Join student teams, always be challenging yourself, and don't wait around for someone else to teach you. the internet is filled, even more so now than when I was in high school, but it's filled with, channels and information, sometimes directly from passionate engineers, allowing you to teach yourself. And if you find what you're passionate about, it won't actually feel like work. There have been many times where people have also tried, not, intentionally or maliciously, but they may give you an opinion or impression that, like, what you're trying to do is overambitious or that it's not possible. And just really don't listen to those people or those feelings, and keep pushing through whatever you want to accomplish. Don't let anyone make you feel like you aren't a part of something that you're passionate about or that you care about, or that you can't achieve your goals. You can achieve anything you want to, and the only person stopping you from doing that is you. You're your biggest obstacle.
I'm a materials research engineer. I specifically work on developing high temperature metals that can be used in jet engines or rocket components. The idea being that if we can invent new alloys that can hold up at higher temperatures or stronger, you can make those technologies more efficient. For example, in the jet engine, if you can run it hotter, it's more fuel efficient, it pollutes less, and so there's a lot of motivation there to try to achieve that. But in order to do that, you have to have metals that can operate and survive at those higher temperatures. And so that's the main focus of my research at NASA, is trying to invent some of those new metals. I felt like the education I got at BHS really prepared me to excel in my engineering degrees at Wright State University and at Ohio State. But I felt really prepared by the time I went off to college, and because of that foundation, I was able to do pretty well with my studies at college, and that helped my chances of being able to work at some place like NASA. Work hard, do your study well, but I think right now even there's a lot more opportunities to get into the space field than there was even a decade or so ago. There's a lot of new companies, SpaceX being one, that are really doing some cool stuff. And you don't even necessarily have to be, an aerospace engineer. They really need scientists and engineers in all the fields. And so, find something that you really enjoy studying, and then, look for, opportunities in the space industry that might open up when the time's right. Like I said, and you don't even have to be, an engineer, or you don't have to get a PhD to work at NASA or, build rockets. There's a lot of different ways that you can contribute in terms of, I work with some amazing machinists down in the lab, and they're almost artists in the things they're able to create with some of the alloys that we're using. And obviously they don't have to go and get a PhD, but they're down there building rocket parts right now. Really, if it's something you want to pursue, there's a lot of different avenues that you can do that. I think the biggest thing is try to stay focused on your studies, and be willing to ask for help whenever you need it. And I think it's also important reach out. If you see a job opportunity that you think would be cool, don't be afraid to apply for it. You never know what could happen, and you might actually get that job and be able to do something that you've always wished to do. So.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope, orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS.
You can hear the calls come. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARIS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
right, NASA family and friends, our first astronaut, Kayla Barron.
I think the thing that's most important to me is just the inspiration of exploration. I think we all have this innate sense to explore, whether you're the one who actually gets to step on the moon or not. I think it changes all of us to know that we can actually do things that would be unimaginable to the generations that came before us. 9/11 happened 8 days before my 14th birthday, so I was in 8th grade. And I was really inspired by how our country responded to that really tragic event. It really made me realize that I wanted to serve and commit myself to something that was bigger than just me. And there's a huge diversity of opportunities in the Navy, whether it's flying a plane, driving a surface ship, driving a submarine, being a doctor. And I spent a week with the submarine warfare community, including a day underway. And I was so impressed by the sailors on that submarine. They just seemed like the kind of people who would teach me how to be a good leader. For me, the dream of becoming an astronaut cemented itself pretty late in my life. I went back to the Naval Academy to work for Admiral Ted Carter. And because I was working with him, I got to go to all of these really cool events and meet a lot of people who I had no business talking to, really. I met one of his classmates, former astronaut Kay Heyer, and she was telling me about one of her shuttle missions where they were building the early space station. And I said, that sounds a lot like a submarine in space. She looked at me and she was like, it totally is. That's exactly what it's like. And that was sort of the lightning strike moment. As a kid, I knew about astronauts. I watched shuttle launches on TV. I knew we were in space, but never seemed like something that I could do. But I had really good mentorship at that time. I shared that dream with my boss, Admiral Carter. He turned to me and he said, Kayla, do you know how you become an astronaut? You apply. And for me, that was the perfect mentorship I needed in that moment. I'm somebody who thinks really hard about everything I do, all the details. And he said, it's actually pretty simple. You just got to put yourself out there and you never know what's going to happen. So I did apply and it ended up working out. Here I am.
I think you're one of my favorite people.
As you can see from the tracker, we are just moments away from our contact. We will not be able to speak with the International Space Station until it comes over the horizon and we can reach it with our antenna. During our 10-minute contact, the space station will travel over 3,000 miles. The International Space Station call sign is NA1SS. You'll hear me use the phonetic alphabet. We often use it in radio to make sure that the message is getting across correctly. So for NA1SS, I will call for November Alpha 1 Sierra Sierra. We will be using our school club call sign W8BCS or Whiskey 8 Bravo Charlie Sierra. It may be necessary for me to call out to the International Space Station several times before they answer. The students asking questions today are Elliot, 8th grade, Corbin, 5th grade, Maddox, 1st grade, Mason, 8th grade, Cody, 5th grade, Tanner, 2nd grade, Kyle, 5th grade, Jocelyn, 2nd grade, and Eris, 5th grade. November Alpha 1 Sierra Sierra. This is Whiskey 8 Bravo Charlie Sierra calling for a scheduled school contact. Do you copy? Over. November Alpha 1 Sierra Sierra. This is Whiskey 8 Bravo Charlie Sierra calling for a scheduled school contact. Do you copy? Over. November Alpha 1 Sierra Sierra. This is Whiskey 8 Bravo Charlie Sierra calling for a scheduled school contact. Do you copy? Over. November Alpha 1, Sierra Sierra. This is Whiskey 8, Bravo Charlie Sierra. Calling for a scheduled school contact. Do you copy? Over. November Alpha 1, Sierra Sierra. This is Whiskey 8, Bravo Charlie Sierra. Calling for a scheduled school contact. Do you copy? Over. November Alpha 1, Sierra Sierra. This is Whiskey 8, Bravo Charlie Sierra. Calling for a scheduled school contact. Do you copy? Over.
November Alpha 1, Sierra Sierra has you loud and clear. How me? Over.
My name is Simon, and we are talking to you today from Bellefontaine, Ohio. Thank you for taking your time to talk with us. November Alpha 1, Sierra Sierra from Whiskey 8, Bravo Charlie Sierra. Are you ready for questions?
I am ready for questions.
My name is Elliot. How long does it take to get used to gravity after being in space? Over.
Hi, Elliot. It usually takes a day or two to start feeling sort of back to normal, but then it takes several weeks to kind of build back up your strength and learn how to use your body again. We kind of learn to ignore our vestibular systems up here, so the signals in your inner ear that tell you how your body's oriented or if it's accelerating, our brain kind of cuts those out because they're not useful to us in microgravity, but when we get home, those are really important for balance and controlling our bodies, so we have to retrain that system and those connections in our brains before we start to feel better.
My name is Corbin. Can you throw objects like a football on the space station? Over.
Hi, Corbin. Yes, you can definitely throw objects up here, and it's pretty cool because we're in an apparent microgravity environment, which means objects seem weightless, so they'll just keep going until they run into something. Over.
My name is Maddox. How far close are you to the moon, sun, or Earth right now? Over.
Maddox, we are 250 miles above the Earth in orbit, in low Earth orbit, so we're not that much closer to the moon or sun up here than you are on Earth. Over.
My name is Mason. How do you train to keep healthy in space? Over.
Hi, Mason. We have a weightlifting machine that allows us to do all sorts of weightlifting like deadlifts and squats or shoulder press, and we also have a treadmill and a bike so that we can stay fit cardiovascularly as well. So we work out for about 2.5 hours every day to stay healthy. Over.
My name is Cody. What is the weirdest thing you have ever encountered in space? Over.
Hi, Cody. I think the weirdest thing to get used to is the fact that things float. It's really fun, and it means you can do cool tricks and flips, but it also means it's really hard to lose things because they'll just float off, and then you might not find them again. Over.
My name is Tanner. How long can you stay in space? Over.
Hi, Tanner. I've been in space for almost 6 months, but humans have spent up to and a little bit over 1 whole year in space. And scientists are really trying to understand how that affects our bodies and how we can stay healthy so that when we go on longer missions to places like Mars, we know how to do that safely. Over.
My name is Kyle. What is the protocol if depressurization occurs on the ISS? Over.
Hi, Kyle. We have lots of procedures to help us deal with that if it happens. If it's a small leak, which it probably would be, we would have time to search for where it's coming from and even patch it. But if it was a really big leak that was happening fast, we would go straight to our spaceships and detach from the space station to evacuate, just so that we can stay safe. Over.
My name is Jocelyn. Who inspired you to go to space? Over.
Well, Jocelyn, I was inspired to go to space by Kay Heyer, who was an astronaut during the shuttle era, and she went to the Naval Academy just like I did. And I got to meet her one time and heard her story, and that really inspired me to want to go myself. And I had some awesome mentors and coaches that encouraged me to apply, and I did. Over.
My name is Eris. What happens if someone breaks a bone or gets injured in another way on the ISS? Over.
Well, first, we have a lot of really cool little medical equipment up here to help us diagnose if somebody's sick or injured, and we also have a lot of things to treat ailments. We have doctors on the ground that we can contact anytime for help, and we're also lucky because we have a doctor on our crew, Dr. Tom Marshburn. So he's our go-to doctor if anything comes up, but so far we're pretty healthy and we've avoided any major injuries. Over.
My name is Elliot. Aside from a clock, how do you know if it's day or night in space? Over.
Well, Elliot, we orbit the Earth 16 times every 24-hour period. So we get to see 16 sunrises and 16 sunsets out the window every day. But we work on a 24-hour schedule just like you're used to on Earth. And so we all sleep at the same time. We get up at the same time in the morning. And our crew likes to use a special function we have on our lights called pre-sleep mode. So in the evening when it's almost bedtime, we turn it to a softer light with less blue wavelength to help us realize that it might be time to go to sleep. Because if you look out the window, it could be any time of day. Over.
My name is Corbin. Do you have a tracking device in case an asteroid hits the ISS or another planet? Over.
Corbin, we do not have a tracking device on the space station, but we have a really strong relationship with the U.S. Space Force, and they track all orbital debris over a certain size, and they would let us know if something might be on our trajectory so that we can move the space station out of the way and it won't hit us. Over.
My name is Maddox. What does the Earth look like from the ISS? Over.
Maddox, the Earth is absolutely beautiful from up here. It is amazing to see the Earth from this vantage point and realize how connected we are on our beautiful home planet, and also see this thin layer of the atmosphere that is the only thing that separates our planet from outer space, and realize how important it is to protect that. So it always takes my breath away, and it's amazing to see the different views at daytime and nighttime all over our planet. Over.
My name is Mason. How does space affect our motor skills? Over.
Well, Mason, you kind of have to learn how to move around again when you first come up here, because we don't walk like we do on Earth to get around. We call it translating. But you have to learn how to control your body, how to sense where you are, and also how to get used to the fact that there's no up or down up here. You could stand on any surface. Anything could be the ceiling or the walls. And so it takes a while for us to get used to that, but our training we do really helps us, and then it just takes some time. Over.
My name is Cody. What are some of the side effects of spending long durations in space? Over.
There are a lot of different effects. There is a higher radiation environment up here because we're not protected by the atmosphere, so the vehicle is shielded a little bit from radiation, but radiation affects our bodies in the long term. In the short term, we can experience muscle atrophy or bone density loss because our bodies aren't forced to operate the same way and support the load of our bodies without the feeling of gravity. And there are other medical effects, like the shape of some people's eyes change and their eyesight actually changes, and so scientists are trying to understand that as well. Over.
My name is Tanner. What is your favorite part of being in space? Over.
Hi, Tanner. My favorite part of being in space is hanging out with my awesome crewmates. It's just such an awesome team to be a part of. I love working with all of my colleagues up here and also our broader team in the mission control centers all over the world that support our mission every single day. It's really special to be a part of it, and we have a lot of fun together. Over.
Thank you for talking to us. November Alpha 1 Sierra Sierra from Whiskey 8 Bravo Charlie Sierra. Actually, one more question. One moment.
My name is Kyle. What resources do you have available on the ISS if something breaks? Over.
Hi, Kyle. We have a lot of equipment available to us up here. We have spare parts so that if something breaks, we're able to fix it. And we have experts on the ground who can always advise us if we're having trouble. And we're also experimenting with things like 3D printers to try to understand how we could print parts that we need up here in space instead of needing to have spares of all the equipment we need with us. Over.
Thank you for talking to us. This has been November Alpha 1 Sierra Sierra. This has been Whiskey 8 Bravo Charlie Sierra 73, and goodbye.
It was great talking to you guys. Thanks for all of your wonderful questions, and keep up that awesome work learning about STEM fields.
Okay, was that cool or what? Oh. I'm overwhelmed. We just talked to people floating on a man-made spaceship. Yeah. But anyway, I just wanted to say when Evan contacted me about supporting their efforts to contact the International Space Station, I thought, this will be cool. So I said, okay, I signed everything and sent it in. Then I took it to the club meeting and I said, here's what we're going to do. And they said, okay, now what? I didn't know. So for the first time in a long time, I had no idea what to do. So that's when I reached out to Tom, W8WTD. He knew exactly who to call, what to do, the equipment to get this thing going. So it kind of turned into a life lesson. Even as old as I am. You still have to turn to the people with the gray hair. I'm serious. It's so all you kids, that think it's cool to blow off your parents and your elders, sit down and listen to them. So, in closing, I want to thank the membership of the Champaign-Logan Amateur Radio Club, especially Tom Delaney, W8WTD, Al Hockley, N8HDR, Dave Saxby, N1JUU, who couldn't be here today, but and then Robert Crumrine, K8KHK, and Chezzy, and Gordon, and all the hams that came together to make us possible. Thank you.
Thank you all for being part of the Space Station Contact. I hope that you've learned from this experience and that it has inspired you to learn more about math and science. If this contact inspired you to learn more about amateur radio, we invite you to take part in our club. Also, there are multiple radio operators around here with us today that would be happy to talk to any interested students after the program ends. A special thank you to everyone who worked hard to make this contact happen. I hope that you each have a wonderful day. Thank you.
Now it's graders' time.
Okay, as Simon said, thank you all so much for coming. That concludes our program. Please come up and mingle with any of the folks up here who have lots and lots of knowledge that they can give you, and thanks again for coming.